Welcome to lesson 80. Today we're looking at transformations at your level. Transformations fit into one of three main categories, right? Reflection, right? Which we sometimes think about this word. Rotation, sometimes think about this word. And translation, we look at this idea. And so with these in mind, we want to apply these two shapes on a coordinate plane. So let's jump right into this and get going. So in this problem, you see we have a triangle ABC, and ABC has been set into this coordinate plane. And what we want to do with this is, first of all, we're going to reflect it. We're going to reflect it over the y-axis, which is this line right here. And in the end, we're going to come away with, a new shape in a new position, and we want to know what those new coordinates are, right? So the first thing let's do is flip it. If we're going to reflect it, right, we got to think about this line being our mirror. If this line is our mirror, that means that this is 1, 2, 3 spaces away. So if it's 3 spaces away on the left side, that means if we were to flip it, it's going to be 3 spaces away. So our first point, we're going to call this B, and we're going to put a little hashtag on it. That helps us understand that this is the new shape we're doing. All right. Same with our C. C is 3 spaces away, so that if it's 3 spaces on the right, on the left, then it needs to be 3 spaces on the right. So this is C, and we put a little hashtag there. And then, of course, our A is another 3 spaces, so a total of 6. And so 1, 2, 3. We have A just like this, and then, of course, we can connect our dots. Real nice and simple like that. But now the question is, what are our new coordinates for our new shape? Okay, so now we use our coordinate plane. We got 1, 2, 3. Right, so we're 3 over, and we're 1, 2, 3 up. Let me change that color because that's hard to see. 3 up. So if we're 3 up and 3 over, that gives us 3, 3 for this coordinate. And here, right, we went 3 over and only 1 up. So that's 3 over, 1 up. And this time we went 6 over and 1 up. And so we have our 3 new coordinates. And as we look at the difference, right, because we flipped it, we have one opposite because we flipped it across the y-axis. That means our x, right, everything changed along this plane. So we have the opposite of what's going on there. Reflection. Okay, reflection. Let's talk about rotation now. If I were to take a shape and I want to rotate it clockwise on vertex B, so it's telling us to rotate right on this point right here, and we're going to rotate clockwise 90 degrees. Okay, so if my shape is currently in this line, what is 90 degrees from this point? Okay, if I want a 90 degrees and I want to go clockwise, I'm going to go like this, and so that's 90 degrees, and so my new line isn't going to be here, but it's going to be right there. All right, it just wants to move. So we rotate it here. Now here's our new line just like that. And so our new point, we would say C, right, our rotation. Right? B is technically in the same spot. And then A, of course, is going to be 3 up. So 1, 2, 3. So we have A, position A. And now I connect my dots as I have now rotated this off of vertex B 90 degrees in a clockwise fashion. So what are my new coordinates? A to the first, not to the first, A, B, and C, right? So B has stayed the same, so we're going to stay -3, 3, right? Even though the shape has moved, the position of B has not, right? C has a new position though, right? So we went 2 more to the left, right? So that's a -5. And it's at the same height as B, so that's a +3. And of course, C and A are in the same spot on that line, so our x is the same. But now it's much higher. We see we're at 3, 4, 5, 6. Now we're at a +6. And so we have our coordinates for that. All right. This one's yours. All right. Translate this shape. It says go 4 down and 8 to the right. Right? So pick a point, go 4 down, and then go 8 to the right. Put your new point down, go to another point, move it, and of course, what are the new coordinates with that? The other part of this lesson has to do with what's called dilation. Dilation has nothing to do with the cat. Well, it involves cats, because cats have dilation. Usually when we think about dilation, we think about our eyes dilating, and when you think about our eyes dilating, we think about our pupils increasing and decreasing in size. And that's really the picture that we have here. Though dilation, in terms of mathematical terms, means getting bigger. That's why we have a little cat getting a big cat, becoming a big cat. And so we have this idea, dilation. Did I spell that right? I did. Oh, good. I can spell. All right. And when it comes to shapes being dilated, usually we talk about what's called a scale factor. How much did it increase by? Right? Did this shape increase by 2? Is it 2 times bigger, 3 times bigger, 4 times bigger? Usually those are the simple scale factors, not scale factors. That's something way different. Scale factors that you might find involved with this process. So let's see what this might look like in a problem. All right. It looks a little weird at first because you got shapes kind of on top of shapes sometimes as you work with different things, depending on where your initial shape starts. All right. So here's our dilation, right? I'm moving that off the side, but let's just talk about where we're starting. We're starting here, right? That's our origin, so that's 0, 0. And very often when you work with dilations, it's going to say what is the point of dilation from. And usually it's going to say the origin, or 0, 0 is that. So what that means is that's kind of where we're growing from. That's our focus point for our increasing on our shape. Now, with that in mind, right, we want to look at our new ideas, right? So we have 0, 2 here, and we have 3, 0 for our A. All right, now let's pull our second shape back in. All right, so this one has been dilated, all right? And because it's been dilated, it has increased in size. So we see the new increase in size. So we have a new point here, a new point here, and it dilated from this point, and this point happened to not change then because of that, right? So it happened to not change because of that. But if we look at our new points, we're going to see that now we have 0, 6, and we have 6. Sorry, 0, 4. I got getting ahead of myself. I was thinking about this number already. 6, 0. And of course, the origin stays the same as 0, 0. So the question is, what is what's known as the scale factor? Scale factor. How much did this shape increase by? How much bigger is it? And so to determine that, we're going to compare our coordinates. You know, what is the relationship between these coordinates, and then of course these two coordinates. And what you're going to see is on this coordinate, right, our 3 increased to a 6, which would be a multiplying by 2. And in this case, our y's increased to multiplying by 2 also. And so we would say in the end that our scale factor is times 2, or yeah, 2 times bigger. Sometimes you might write it like this also, or just write it in words, because this isn't really increasing down here, and our C, because it's 0. Right? Stayed there. Whew, that's a lot to take in, but hey, you can do this, because if you couldn't do this, you wouldn't be here. You wouldn't be watching this video. You'd be somewhere else completely. All right. All right, then for your sample problem, let's see if you can answer this question. What is the scale factor from this dilation? So we're working with ACBD as our shape and the new dilation here. So we'll go ahead and solve for what is the scale factor. What is the scale factor? And we'll see you in class as you work with transformations.